A complex repetitive discharge, or CRD, is a spontaneously generated potential from a group of denervated muscle fibers. It is usually seen during assessment of insertional and spontaneous activity. In past, it was also called by many other names such as bizarre high frequency discharge, BHFD, or pseudomyotonic discharge, etc. Those terms should not be used. A gain setting of 50 to 200 microvolts per division is adequate to see the discharge. The sweep speed is usually 10 milliseconds per division. The signals are displayed in a free-running EMG mode. The relatively constant mechanical sound of the CRD can be heard quite easily. Amplitude trigger can be useful to demonstrate the repetitive pattern of the discharge. A CRD contains a group of action potentials that occur in a sequential manner. This gives it a complex appearance. In this example, we can see 8 such time-locked action potentials. This group discharges repeatedly, and hence the term complex repetitive discharge. The discharge can begin spontaneously or following needle movement. The discharge may last for a few seconds or even minutes before it stops abruptly. The discharge frequency is variable from 5 to 100 Hz. In this example, the sweep speed is 10 milliseconds per division. The duration of epoch shown is 100 milliseconds or 1/10 of a second. We see the discharge 6 times in 1/10 of a second or 60 times per second. Hence, the frequency of this CRD is 60 Hz. The signal amplitude is variable among the different potentials in the CRD and can range from 50 to 1000 microvolts. The CRD has a very characteristic high pitch and mechanical sound. The high pitch reflects many sharp and short duration action potentials in the signal. The configuration of waveform is quite stable. The inter-discharge interval is relatively constant. This explains the static and mechanical sound. The waveform and sound of CRD can change abruptly. Between these sudden changes, the waveform and sound remain relatively constant. The CRD begins in a group of denervated muscle fibers. The fibers have a hyperexcitable region called a hotspot where they can be stimulated by action potentials from neighboring muscle fibers. This is called ephaptic transmission. One muscle fiber, called the pacemaker, depolarizes spontaneously to produce a propagating action potential, hence the sudden onset of the CRD. As its action potential moves towards the tendons, it activates the neighboring fiber at its hotspot, and it produces an action potential. As this action potential propagates towards the tendons, it will activate another neighboring fiber at its hotspot, and that in turn will activate another neighboring fiber to produce an action potential. In this manner, more and more muscle fibers can produce action potential following a single spontaneous discharge of the pacemaker. Let's look at the same process in a cross-sectional view. The pacemaker fiber discharges and returns to its resting state. By ephaptic transmission, the potential passes to muscle fiber number 2, and then to fiber number 3, to fiber number 4, and fiber number 5. Note that fiber number 5 is next to the pacemaker fiber, which also has a hotspot. Thus, fiber 5 ephaptically reactivates the pacemaker. A loop is thus formed that continues to activate these muscle fibers sequentially and sustains the discharge. The time to reactivate the pacemaker fiber is the inter-discharge interval of the potential. If there are more fibers in the path, or if the fibers conduct the action potential slowly, the inter-discharge interval will be longer and the rate of CRD will be less. In general, CRDs have a firing rate of 5 to 100 Hz. If the ephaptic transmission fails, the sequential activation of muscle fibers will stop. Hence, the complex repetitive discharge will also stop abruptly. Here is another model where fibers 1, 2, and 3 make the loop to sustain the CRD. Fibers 4 and 5 are also activated and contribute to the CRD waveform. If these fibers, either number 4 or 5 or both, drop out due to failure of the ephaptic transmission, the CRD will continue, but its waveform will change. The sudden change in the waveform can also be seen and heard on the audio monitor. Some muscle fibers can also join the CRD and hence its waveform can change. Since the muscle fibers are activated without the neuromuscular junction, the potentials do not show any jitter that is associated with neuromuscular transmission. In this example, 5 triggered sweeps are overlapped, and they show almost perfect superimposition, that is, no jitter. The CRDs can be found in many neurogenic and also myopathic conditions. The presence of a group of denervated fibers suggests a more chronic disease process.